SingleStore, the world's database for data-intensive applications. You've heard it, data-intensive application. What does that mean? Data-intensive applications are those where the data itself becomes a constraint you worry about. You don't worry about necessarily about compute, storage, networking, but how to manage the data, its complexity, its volume, its variety. Data intensity manifests itself in many ways. Just thinking about if you plan an application that you might need 3 or 4 databases that you have to stitch together to an application creates data intensity. Well, SingleStore can help you manage that data intensity. I'm happy to be joined today by 2 marvelous users and partners of SingleStore. I want to introduce them to you, and we'll learn a little bit about what makes their applications data intensive, their developer experience, and find out how SingleStore adds value. My guests are Matt Lockyer. He is Director of Developer Relations at Near Protocol. Hi, Matt. Near Protocol is a blockchain network with decentralized compute and storage. We'll learn a lot about blockchain applications. Erik Bovee is Vice President for Business Development and an investor at MindsDB. MindsDB is an AI platform that brings machine learning to the source of the data. And MindsDB was recently recognized as one of the 50 AI companies in America to watch. Congratulations on that. Welcome, Matt and Erik. Let's start by introducing what you do, what your product's about, what your company does. Let's start with you, Matt. Tell us about Near Protocol.
Hi, pleasure to be here. Thanks for inviting me. So Near Protocol is a blockchain, just like any other sort of cryptocurrency network out there, like Ethereum. We have smart contracts. So basically, we're doing a lot of decentralized compute in the cloud. And what that means is that we have a lot of users who basically are hitting our network in a decentralized, permissionless way. So they're basically just signing transactions cryptographically, and they're broadcasting them up to an append-only database in the cloud. So we essentially deal with a huge fire hose of data coming from a lot of different users. What's interesting, and where we sort of are exploring using SingleStore and seeing some real performance benefits, is when app developers who develop applications on top of this network, this append-only database that is just a huge fire hose of information or data coming from a bunch of different users in the cloud, is when these app developers want to do queries on that data. So they want to look at data that is coming from only their application. So that's a little bit about what Near Protocol is. Myself, I'm the director of the engineering team for the developer relations. And basically, I help these app developers build their applications and deploy them on the Near network.
Thank you, Matt. Erik, tell us about MindsDB.
Thanks. Pleasure to be here. So MindsDB is a machine learning service that provides a suite of advanced, leading-edge, pre-built machine learning models, and then features that automate a lot of the tasks around machine learning. So data cleansing, data prep, model selection, training, hyperparameter tuning. So creates efficiencies in operationalizing machine learning. And then probably
one of the most important aspects of MindsDB is that it runs at the data layer. So you connect your database to MindsDB, and you can train models and run predictions and create predictive data directly in your database using SQL commands. So, which are then immediately available to the application layer. So it saves a lot of time in pipelining data around from different applications. So essentially, in a nutshell, MindsDB gives your database a brain, and it creates vast efficiencies in operationalizing machine learning.
And what's the benefit of being close to the data in machine learning versus, for example, creating a data lake or a Hadoop cluster and moving the data and analyzing it there, as it's often done?
Right. Yeah. So that's the common way of doing it today. And so there's a theory of why it's good to run it at the data layer, and then there's some practical consideration. So the theory is that structured or semi-structured, but mainly structured data running, let's say, in a SQL database has a lot of similarities with your machine learning models. There's code and schema that define your data in the database. There's a graph and code that define the machine learning model. Things like your database columns equate really well to features in your machine learning model. So they're just kind of a nice theoretical fit. We thought, well, this should work. But then we realized what happens when people build machine learning models today, they run them kind of like PhD projects. You've built a homemade model out of TensorFlow or PyTorch. You're extracting data from a sluggish data lake, you've got CSV files, you got a SQL database somewhere, and you have to pull all this data, you have to do a lot of data wrangling, transformation, you load it into a machine learning application, train it, generate predictions, and then you reverse the process and you have to pipe that data back into another application at the application layer. And that can take weeks or months to operationalize your machine learning, and we just cut out all the steps, basically. Makes machine learning much, much easier.
And there's a great deal of automation involved.
There's a great deal of automation involved. But to be very clear, I mean, this isn't job threat to data scientists or machine learning engineers. What we do is we operationalize a lot of the bad and dumb tasks. We provide a suite of very advanced and high-performing models that compete well with, say, OpenAI and cutting-edge models. But often, you'll have a bespoke model that's very particular and trained to the task. We allow data scientists to bring their own models, and we handle a lot of operational things like model versioning, maintenance, that just make their lives easier. Yeah.
Thanks. Matt, blockchain is often associated with cryptocurrencies. We hear about blockchain applications. You mentioned it's kind of an append-only ledger. Tell us a little bit about blockchain technology and why that is important in your protocol.
Absolutely. So blockchain technology, as I mentioned, it's kind of an append-only ledger. And what we're really trying to do with blockchain technology is create an immutable ledger or history of digital ownership. So yes, it's commonly associated with cryptocurrencies, and typically you use a cryptocurrency to, power the network to basically pay to perform transactions on this shared database. And what that does is that creates a security model around who can append data to this database, and it reduces attack vectors like spam. And it allows you to sort of tie in with consensus algorithms and prevent things like double spending. But before I kind of go down the crypto route, I'd like to talk about more interesting applications that can be built on these blockchains. So I mentioned digital ownership, and you can essentially have users that essentially own a property. So they can own a deed or a title to a digital object, and because it's immutable and because it's sort of cryptographically secure, they are the only owner of that digital object. So while you may be able to copy a JPEG or a 3D a 3D model or a video file from one computer to another, you can using a blockchain network basically define one true owner of that object. Now that has applications in obviously VR, AR, video games, even social networks, and all sorts of other sort of yet to be defined use cases.
Thanks for that. Data-intensive applications. So in what way are your developers, your users, your customers facing data intensity? Is it the volume of data? Is it the quality of data? Is it the complexity of the environments? Is it the number of queries, the number of users in their applications? Talk a little bit about that. We'll start with you, Erik, and how SingleStore helps you at MindsDB to make sure that your users don't succumb to data intensity, but take advantage of it.
Right. So there are a couple of aspects to this. We don't suffer so much from the Firehose problem that Near does. We're a B2B application, and our users and customers are business analysts, data scientists, database developers. But we do one of the places where we find data intensity can become challenging is in training of machine learning models, where you can have huge amounts of data to train. For instance, a language processing model. People I'm sure have heard of GPT-3, the OpenAI model, which models like that, we have something comparable, can cost in the millions to tens of millions of dollars to train on dedicated GPU infrastructure. And so working with SingleStore, there are a number of features that we can get into that really help to speed up the inference. There is automated statistics generated, there are histograms, there are other things that really reduce the training time and make that very useful. We handle that on our side as a cloud service by economizing on the compute infrastructure. So if a customer wants to come and sign up for our service, they won't have to invest in the very intensive infrastructure used to train using the large amounts of data that are often used for sophisticated machine learning models. So that's one way of doing it. The other aspect is on the inference side. When you're generating predictions, there are a certain subset of use cases that require real-time predictions, and those can be very challenging. You have to generate predictions quickly and then often pipe them into a streaming service. Maybe you're using Kafka or something. So that could be separate infrastructure from your database. SingleStore has some really nice features and parallelization that allow that to happen very quickly. They're built in data pipelines, so you actually don't need that infrastructure. You can run real-time inference and do things like anomaly detection, algorithmic trading, preventive maintenance for industry, running on your existing SingleStore clusters.
Don't have to move the data. It's all in the database, reducing complexity and performance.
And it's fast, yep.
Wonderful. Matt, in your applications, in your protocol, what is the data intensity? You mentioned the Firehose, and describe a little bit the volumes of data that your developers are dealing with. Some people think blockchains are being updated only once every 10 minutes. Your blockchain is moving pretty fast, isn't it?
That's correct. Yeah, we have actually 1 second block times. So we can actually see hundreds of thousands of transactions in a really short amount of time. And because the blocks are basically being produced, and these are basically the state change of this shared database, because it's being updated every second, app developers typically want to flip and share that information with their users so that they can make future decisions based on that shared data. But the issue really actually comes down, and where it's very interesting to use SingleStore is in basically getting just a small kind of subset of that fire hose of data out of the blockchain. So essentially, a bunch of users around the world will make transactions, these state changes to this database. They'll go into this shared database, but we need to somehow be able to index them and lay them out into tables and views that you would sort of typically use a traditional kind of Postgres database or something, and you would use like a materialized view. But we can't actually produce this kind of stuff fast enough and at sort of an economy of scale to cater to hundreds of different developers that want to look at just little slices of this data. So we can use SingleStore to basically show those aggregated query views and basically information about what they want to see that is pertaining specifically to their application in seconds, what would usually take us minutes to kind of churn through on a shared resource using a traditional database. So that's where I think it's actually really fascinating and providing like this incredible power to basically just surface aggregated kind of data results out of what is essentially the actual append-only database is just it's like a key value store because it has to be very, very fast because we have a bunch of computers in the cloud running that. Then we have to bring it into tables. Then we have to get just a slice of that, and sometimes often an aggregated view of that out to the app developer. And I mentioned that the turnaround time for this, like data going in a 1 second block time, and then often the user is returned to their application after maybe 1 or 2 seconds, and the app would like to basically, query, was that a success? Was that not a success? And did anyone else also, try to make the same state change? Because that's going to impact like future decisions for the user. This all has to happen like in concert very, very quickly. So that's where SingleStore is really interesting for app developers, is that we can pass on this power to surface these views to users, within seconds.
That's a great story, Matt. And that's also an aspect of data intensity. If you plan your app and you think, oh, this cannot be done in real time, or I cannot meet that SLA, then you're stepping back and you may be planning a suboptimal application based on technology that's available. SingleStore is there to help, and we can fix that, and we can actually help you elevate your data intensity. Erik, Matt, thank you so much for being with us today. Thank you so much for your partnership. Congratulations on your wonderful companies, and we love working with you and look forward to continuing that.
Thank you very much. It's been a pleasure.